All right, ladies and gents, let's talk about binomial experiments. So a binomial experiment consists of two possibilities, success or failure. So success doesn't necessarily mean a good thing. For instance, if you're conducting a study about cigarettes causing cancer, and you're trying to see, do cigarettes cause cancer? The yes would actually be the success, and the no would be the failure. But it has to be a yes or no, success, fail, something like that. It can't have multiple different possibilities. It has to be a yes or a no. And it also has to have a set number of trials. So you can't just go until you feel like it. You have to have like, okay, I have exactly 117 people. It has to be a set number. The probability of success has to be the same every time you do the trial. So success doesn't change. You're flipping a coin, it's always 50-50. So heads is always 50%, tails is always 50%. Failure is represented by Q. It's also got to be the same. So success is P, failure is Q. Now, Q is equal to 1 minus P. Well, why? Because it's either a success or fail, right? It's 100% probability for everything, which 100% is a solid 1. So whatever P is, 1 minus P has got to be Q. Okay. So let's look at some examples. Randomly selecting a month 30 times, and the success is January. Failure would be not January. So we got a set number of trials. We got 30. Okay, so that's good. Pass, fail. It's January or it's not January. What's the probability of being January? 1 out of 12. How many months are not January? 11 out of 12. And you can check it. 1 minus 1/12. Yeah, obviously that is 11/12. Next, randomly selecting a card 100 times. So obviously we're putting the card back because there's not even 100 cards in a deck. So N is 100. Success will be heart. Failure will be not a heart. Well, there are 13 hearts out of the 52, or you could just say it's 1 out of the 4 suits. I like to simplify it, makes the number smaller to work with. So success, P, would be 1/4. There's 1/4 chance of being a heart. 3/4 of not being a heart. So those two are binomial experiments. And it does have its nice little formula to calculate the probability. So here it is. So remember this big C that represents a combination. So it's NCR. N is the number of trials. R is the number of successes you're looking for. P, well, that's probability of success. Q, probability of failure. Okay. Let's see how this works. Mark tosses a coin 25 times. What is the probability that lands on heads exactly 7 times? First and foremost, write down what N, P, R, and Q are. 1 second, please. And I'm back. Sorry about that. So Mark tosses the coin 25 times. That's N. That's how many times we're doing the experiment. We want to know what the probability is that it lands exactly 7 times on head. Heads. So R is 7. We're actually going to kind of interchange that. Sometimes we use X, sometimes we use R. P, probability of success. We're going to assume, if not otherwise stated, that it is a fair coin, so 1/2 is heads. Q is, well, 1 minus 1/2 is still a half. Okay. So here's the formula. Just plug and chug. 25 C7 times 1/2. I would advise putting your fractions in parentheses. As long as you format it correctly, it won't need the parentheses, but just be safe. Put the parentheses. 1/2 to the 25 minus 7. Sure, you could subtract it there, but there's no reason to think about the arithmetic. Just type it in the calculator and be done with the dang thing. So if you recall, the combination button, shift divide. So I'm going to do 25, shift divide, 7. Now make sure you actually put the multiplication symbol. If you don't put the multiplication symbol, it'll confuse the calculator. And I'm going to get there with the parentheses. You don't actually have to have it, but just do it anyway. And we're going to raise that to the 7th power. Times. I'm going to do it again. Thank you, my love. 25 minus 7. I am indeed talking to my computer, my love. So this is the probability that if you toss a coin 25 times, it'll land on heads exactly 7 times. We can multiply by 100, make it a percent, or you can just write it out like this. For now, I'm just going to say write it 4 decimal places and round. Don't not round, round. 4 decimal places. 0.0143. So I don't know how I can stress this enough. You must be able to round, and you must be able to round correctly. It's no matter what class I'm dealing with, it's always been an issue for rounding. I don't know why. You look at the number you're rounding to. We're rounding to 4 decimal places. You go to the next one. Is this number 5 or bigger? Leave that one alone. Stays at 3. If this were 5 or bigger, then you'd go up. This would be a 4. And that's how you round. Yes, there are fancy methods of rounding that you probably won't ever worry about, but in our cases, that's how you round. So this is the probability that R equals 7. Now, I do want you to write that out because it won't always be an equals. So that's the probability right there. Let's do another. And then I'll show you how to do it with the calculator. But you just use a calculator. I'm going to show you how to do it without using the formula and use the calculator. Now, depending on who you do have for stats, you may have to use this formula. It's not that bad till we get to ones that aren't exactly, but it's not that bad. Just use the formula. Hopefully you have a formula sheet. Spinner below is spun 10 times, so that's our N. Again, write this information down regardless of which way you're doing things. What's the probability that it lands on red exactly 6 times? So R is equal to 6. And then the probability of success. Oh, 1 second, please. About that. So P, that's a probability of success. So we're looking for red. There's 1, 2, 3, 4, 5, 6 different options, and 2 of them are red. So 2 out of 6 or 1/3. That would make Q 2/3. All right, so I'm going to do this one by hand, and then I'm going to show you how to do it on the calculator. So I'm going to write out what I'm going to do. So P to the 6th, Q to the 10 minus 6. See what happens if we type that in there. So 10C6 times 1/3 to the 6th times 2/3 raised to the 10 minus 6 equals that, and we're just, even if it's a fraction, make it a decimal. 0.0569, that next number is a 0, so it stays a 9. 0.0569. And that would be the probability of R equaling 6. R is exactly 6. Now, let me show you how to do it in the calculator real quick. So if we take our calculator, you're probably going to want to write this down if you're having the same exact calculator, which I suggest you have for my class. And then if you have another class, it's a very cheap and powerful calculator. Get it. Let me have that information. That's what I need. So we're doing a binomial probability. It's a distribution. Binomial is type of distribution. So we're going to go to mode. I don't see distribution on here. Well, you see this little down arrow? Hit it. Distribution, number 3. And you see it's got another down arrow. Well, we have 2 options. We have binomial PD and binomial CD. We'll talk about when to use which in a little bit. For now, just know if it's got an equal, you're doing PD. Now, you might have a list of data or you might have variables. We got the variables. Alexa, stop. It asks for X. That's what we call R. They're interchangeable. Depends on what book you read. So X, or R in our case, is 6. That's the number of successes. Total number of trials is 10. Probability of success is 1/3. Yeah, it looks all strange on here because it's not in math type in any mode except for mode 1 or 2. But it's 1/3. And there we go, 0.0569. Boom, just like that. So if you have this calculator and your teacher allows it, there it is. So let's try. We're going to do the next few just with the calculator. I'll actually skip around a little bit. The most important thing is getting the information from the problem. If you can do that, and you can type in the calculator, you're good to go. Multiple choice test with 4 choices for each question. She guessed on the last 5 questions. Was probably she got exactly 3 questions correct. I like to write in first. How many questions did she guess on? 5 of them. How many she want to get right? 3 of them. What's the probability she got 1 right? 1 out of 4. Usually it's 1 correct answer on a multiple choice test, and there's 4 options. And failure would be 3 out of 4. Notice we didn't need to type in Q into the calculator because, well, if we know what P is, 1 minus that is Q, so it can do that itself. So go to mode, down, 3, 4, 2, type it in. 3, 5, you can do 1/4, you can do 0.25, you get the same result either way. You cannot do 0.333 though, that's not the same as 1/3. And this is what the calculator spits out. Come on. Thinking, it's thinking about thinking. Oh, that's not at all what I want to do. I have no idea what it's going to do. Just give me that. Cool, ignore that. No, get away. Sorry. That's just write the thing down. Now, that's the answer. Let's make sure we can round it, because if you don't round correctly, I will take off points. Your test in college might be on the computer. So if you round it wrong, it is wrong. So 1, 2, 3, 4. This is the guy in question. Is he going to stay an 8, or will he move? Will he become a 9? The next number is bigger than 5, so this guy's going to change to a 9. 0.0879. That's it. Probability of R equals 3 is this. And let's do the next one. Chad randomly chooses a card from a standard deck 30 times, which probability that he gets a diamond exactly 4 times. N, 30, R, 4, P. There's 1/4 of them are diamonds. Q, 3/4. So if you're already in there, you can just hit the AC button to get back to the beginning. R is 4, cross it equals. N is 30, and 0.25 still 0.0604. So it's still probability of R equals 4. I'm not gonna write it there, down next. Let's go through these real quick. 30 balls. One is randomly selected 12 times. We're probably getting a prime number exactly 5 times. Well, what are our prime numbers up to 30? Let's see. There's 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 out of 30, or 1/3 for P. And Q would be 2/3, or 20 out of 30 if you want to look at it that way. We get equals, it also gets back there. So R is 5, 12, 1/3. This one, you got to use a fraction. There's no getting around it. You can't do a decimal for 1/3. 0.1908. This is bigger than 5, so that, well, that's 5, so this rounded up. However, the customer at a store receiving a coupon print on the receipt is 1 in 8. 20 customers visit the store, what's probably exactly 3 of them receive coupons. So, N, 20 peeps. R, exactly 3. Notice the exactly in bold, that's because it's kind of important. Probability, 1 out of 8. And Q would be 7 out of 8. Calculator, 3, not 20. 3, 20, 1 out of 8. Now, if you have to know that decimal off the top of your head, go for it. I don't. 0.2300. Put the 00. You might say, but it's the same thing. It's the same value, but it's not exactly the same thing. That goes into significant figures. You can ask your science teacher about that one. You should know about significant figures. Significant figures, significant digits, sig figs, sig digs, whatever you want to call them. Put 4 decimal places. Not 1, not 2. I don't care if they're 3 zeros right here. Put them 4 decimal places. It matters. A negative chance, the probability winning is 30%. 15 games are played. That's probably winning exactly 6 times. That's terrible R. Plug them in. Probability is 30%, which is 0.3. If you convert that to a decimal. I don't like using percentages, so I'm going to make it a decimal. Q would then be 0.7. They got to add up to 1, right? 6, 15, 0.3, and oops, 6, 15.3. We get 0.1472. Doesn't change. 0.1472. Now, if you want to look at that as a percentage for whatever reason, probably the problem told you to or whatever, multiply that by 100, you get 14.72%. Yay, who cares? Traffic light is red for 20 seconds, yellow for 4 seconds, and green for 36 seconds. Find the probability of the next 12 cars that randomly arrive at the light exactly before we stop by a red light. So we got n is 12. R is 4. Now this, I don't actually like this problem because, well, people stop at different times. Like they see the lights green and then they get closer and it's the yellow, like, oh, I'm gonna make it, and they might run underneath the red light. We're gonna assume that when their nose is at the spot that they should park, it's gonna be red 4 times. That's what we're calling it. So how many seconds are there? There's 36 and 4 is 40 plus 20, that's 60 seconds, or a whole minute. So it's on a 1 minute cycle. And of those 60 seconds, it's red for 20 of them. I am going to simplify that. That's 1/3. Q will be 2/3. So in actuality, I don't like this problem, but we see what they're trying to do. 4, 12, and 1/3. 0.2384. All right, so that's the probability of R being equal to 4. Set exactly. Ready? Ready? Let's look at number 9. Kyle tosses a coin 10 times. What is the probability that he gets tails? At least 8 times. What is different? Hopefully you notice the giant word in, well, words in bold. At least. Not equals, not exactly, at least. So, n is 10, sure. R is at least 8. So R is greater than or equal, that's terrible, greater than or equal to 8. Notice it's not equal to 8, it's greater than or equal to 8. And P is a half, right? It's a coin. Q is a half also. I'm going to do this problem by hand, and then I'll show you, well, I'll make a chart with you to see how to use a calculator. It requires a little bit of thinking on how to use the calculator for these. So just let's look at it from there. Now, at least 8. What does that really mean? It means it could be 8. It could be 9. Or it could be 10. All right, so sorry guys, some stuff happened at the end of the last piece of this video, so I'm just gonna reshoot it. So Kyle tosses a coin 10 times. What is probably that he gets tails at least 8 times? So 10 times is n, R is greater than or equal to 8. So it's not just equal to, it's greater than or equal to. And this is binomial, so that means, you know, we got natural numbers for the number of trials. We can't try something a half a time. So if it's greater than or equal to 8, that means it's 8, 9, or 10. You know, we have a total number of trials of 10, so it can't go past that. Probability of heads or tails is equal, it's half, either way. So here's our formula. So we're going to calculate the probability for 8, 9, and 10 and add them up. And I'm just going to, I already did that. So there's a probability for 8. That's probability for 9. That's the probability for 10. And that's what we get when we add them up. Now notice I did each of these individual ones, instead of 4 decimal places, I went 6. I wanted a couple extra decimal places so that whenever I did add them up and round, I wouldn't have a double rounding error. So if you're rounding to the 4 decimal places, take your intermediate answers out a couple more decimal places at least. That way you'll be safe with the rounding at the end. Now, this is a lot of work, yeah. So it depends on who your professor is, if they let you use a calculator or not. I like the calculator, I'm gonna let you use it, and I'm gonna show you how to use it. So, there's 2 different binomial functions on the calculator. There's the binomial PDF, and binomial CDF. So that's point distribution and cumulative distribution functions. So what this one does, it gives you for exactly that one data value. So this is for equal to, this is for exactly. What the CD does, it's cumulative, so it does less than or equal to. So that's, at most or something. And there's all kinds of different wordings you can use. Just think about it in terms of your symbols, and then you know which to use. And when you type it in the calculator, you're going to have R, or X, as the calculator uses X, N, and then P. That's the order you type your information in. We'll look at a few examples in a minute. Now, from here, you can get everything you need. So what if you say not equal to? So some sort of not. Well, you calculate your probability for exactly, and by rule of complements, it's got to be the opposite. So you get your probability from the calculator, go to mode 1, and then 1 minus your answer. So you're going to do 1 minus and the regular information. So you're going to type this into the calculator, into binomial PD. It's going to spit out a number. Go back to your home screen, 1 minus that number, which is going to be stored as your answer. So let's think about this. The opposite of less than or equal to is greater than. So more, whatever. So this would be 1 minus R, N, and P. So now let's think about what less than actually means. Again, it's binomial. There's a fixed number of trials, and you can't have a piece of a trial. So if we look at this one, it's 8. So if it was less than 8, what's the very first number before 8? If we're doing in natural numbers, that would be 7. So what we do is we take 1 away from R. So instead of R, we're going to type in R minus 1. N and P. And then the complement of less than is greater than or equal to, which is what we have on this previous problem. Least. So we're going to do 1 minus the answer we get from this, R minus 1 and P. So I know this looks like it's a lot to remember, but it does save you from doing all this work and most likely making an error somewhere. So let's try using this strategy in the calculator. So we're going to do binomial CD. We're going to type in R minus 1, N, and P. Take that answer, do 1 minus that answer. On this problem, we should get 0.0547. Let's find out. So mode, go down to distributions. Number 4 is binomial PD, but we need a binomial CD, so we go down. And then number 1 on the next page is binomial CD. We have variables. X is our R. So we said we have to do R minus 1. So 8 minus 1, which is 7, obviously. 10. And then P was a half. You can either do 0.5 or a half. Now, if it's not a terminating decimal, make sure you leave it as a fraction. And we get P is 0.95. That's not that. You're right, it's not. We still have to go back to mode 1, do 1 minus our answer. And that is 0.0547. 0.0547. There we go. So depending on what symbol we have here determines what steps we need to do here. So I'll leave that up there for a moment, screenshot it, write it down, I don't care what. Okay. You can pause the video and go back if you need to. Let's see what's going on here. So what I'm going to require of you, I want you to list out the pertinent information and tell me what it means. So I'll give you an example. Kara randomly chooses a day of the week 6 times, so n is 6. What's the probability of choosing Tuesday or Thursday at most 3 times? So R at most is less than or equal to 3. And the probability of that is going to be 2 out of 7 because it's Tuesday or Thursday and there's 7 days in a week. So of course Q would be 5 out of 7. Now I don't necessarily need Q for using the calculator, but we'll put it anyway. So interpret. What does R less than or equal to 3 mean? That means R equals 0, R equals 1, R equals 2, or R equals 3. So if we're doing this by hand, we'd calculate these 4 probabilities and add them up. And we're not going to do that because we're going to use the calculator. We can check this. I'll check it with this one, just for this one example, but let's do it in the calculator. So we're going to go to a CD, and if you look back at the chart, you will see that less than or equal to, that's just regular. So a regular old CD. R is 3, N is 6, and P is 2 out of 7. Definitely want to leave that as a fraction. And we get 0.9403. So just for this one example, I'm going to do it, each one of these individual probabilities, and add them up. But I am going to use a calculator. So I'm going to go to a PD, the point distribution. So that does the exactlies. So if we have exactly 0, N is 6, P is, that is 2/7, it saves the last information you did. So we just have to change the R value, the X value, each time. You get 0.1328. I'm just going to go 4 decimal places. We can see it'll be close. 0.1328. And then if X is 1, 0.3187. If X is 2, 0.3187 again. If X is 3, 0.1700. Yes, those zeros are important when you're writing down the probability. If you type in the calculator, they won't make a difference. But when you're writing down your actual probability, make sure you have 4 decimal places, including any zeros you got. I'm just going to add these up and see what we get. You get this. And yeah, you don't have to type in the zeros there. Let's see. It is 0.9402. So a rounding error. But yeah, it's the same thing. So that's how we can do a less than or equal to in the calculator without going through every one of these things. I would advise remembering this chart or being able to figure it out at least. Let's look at 2 more examples and then we'll call it. Soda company prints prizes inside their bottle caps. The probability of winning a prize is 1 in 3. Out of 8 bottle caps, what is the probability that at least 5 are winners? So we have 8 bottle caps, so N is 8. R is at least, so greater than or equal to 5. P is 1 out of 3. So Q would be 2 out of 3 again. We don't need that for the calculator because the calculator can do basic math. So what does greater than or equal to 5 mean? That means R equals 5, 6, 7, or 8. So by hand, you'd have to calculate all those probabilities and add them up, and yes, it's not what we want to do. So instead, greater than or equal to, that's 1 minus, and you do R minus 1. Let's look. greater than or equal to 1 minus and r minus 1. So eventually you'll probably just remember. But if not, write the chart down, look at it. Make sure you can write it down for the test though. So I have to take 1 away from here, so that's going to be 4. N is 8. P is 1/3. Definitely have to leave that as a fraction. I get that. That's not my answer. Go to mode 1. 1 minus my answer gives me my answer, 0.0879. So that is the probability of R being greater than or equal to 5. All right, one more. Seven boys and 5 girls on the debate team. Each week, one is chosen at random to lead the debate. For the next 10 weeks, was probably that no more than 4 girls are chosen to lead. Okay, so 10 weeks, so N is 10. No more than 4. So R is less than or equal to 4. Probability of it being a girl, well, there's 5 of them out of 12 people. Q would then be 7 out of 12. What does less than or equal to 4 mean? R is 0, R is 1, R is 2, R is 3, or even R is 4. So 5 probabilities to calculate and add up by hand. Sounds like a lovely time, right? Or just take your calculator. Mode, distribution. It's a cumulative distribution, and it's a regular old cumulative distribution using variables. We have 4, 10, and 5/12. 0.5908. That's the probability that R is less than or equal to 4. And that's it, done. There's nothing else to it really. So again, make sure you can either make or remember this chart. That's the only tricky part. And make sure you can read and know which symbol is which. All right, that's it. See ya.